We continue with the next talk that will be given by LONGi. We hear from Vitor Rodrigues, who is the Technical Director, Utility Europe for LONGi Solar, about a case study of solar projects with bifacial modules and trackers. Vitor, the floor is yours.
Hello, good morning. Thank you, Michael. So first of all, thank you for the invitation, and let's then start our presentation. Michael, can you see my screen?
Yes, just
a second, because it was on the wrong slide. And now in the presentation mode, is it working?
Not yet. Can you click once again? Now it's working. Perfect.
It is working now?
Yeah.
Okay, thank you. So again, thank you so much for the invitation. So the idea is also to speak a little bit about the bifacial technology of the modules in real cases. So probably I will repeat some things that the colleague from Trina just mentioned, but at least we can understand that the bifacial technology is getting mature, is very reliable, and we will discuss this a little bit now during the presentation. So also just a short introduction about LONGi, the company that I represent. I'm the technical director for Europe on the utility sector, and LONGi is one of the largest module manufacturer. We started with the polysilicon, the wafers for monocrystalline. So we introduced the monocrystalline with a different cutting, and we came down with the prices, making the monocrystalline as the main technology on the modules in nowadays. Then we entered the modules, and maybe the highlight that I would also like to bring is that we are also looking to other sectors like hydrogen. So last year we acquired a company for hydrogen, and we will also trade products in hydrogen besides using the hydrogen for our own carbon reduction emissions. Okay, so some numbers from LONGi. This is our results from last year. Maybe highlight here because these are records. We are the main or the top manufacturer of wafers. But last year, we also had a record of shipments of 38.5 gigawatts of modules. This is our capacity. We have right now 60 gigawatts. We expect by the end of the year to have 85 on the modules, 105 on the wafers, and also expecting to grow for next year. Besides all the new sectors like hydrogen and all the strong bets, we are also looking for programs regarding the emissions. And just a highlight, we assumed that by the end of next year, we will have our first manufacturing facility total neutral, and it will be a wafer facility. Presenting LONGi, let's start a little bit with some concepts regarding bifacial so that we understand how does it work in the real life, in a real system, so on site, and what can we expect from bifacial. Maybe the most basic but important concept is that when we speak about bifacial modules, we are speaking about bifacial cells. So the main manufacturing change is on the cell level. And I can already tell you that, for example, in LONGi, we are not manufacturing mono cells right now. The penetration and the demand on bifacial is so high, and I will show you some numbers, that right now our cells are bifacial. Then we can manufacture monofacial modules or bifacial modules, but all of the cells that we are manufacturing right now are bifacial. And why the demand and why bifacial is so such a hot topic? For example, if we look from the efficiency point of view, we see that we still have a long way to increase efficiency, but that is a technology that is mature and that we can also work on it to improve the efficiency of the module. The same like we did on the monofacial, but in this case, of course, what is most important is what is the bifacial factor that we are achieving and that we expect to achieve. I leave you here two numbers. If we test the bifacial PERC, P-type PERC, we have already 75%. In most of the cases, we got even higher than 75%. But when we look to the new technologies that we are studying, like the N-type TOPCon and others, we can even reach 80% or more. So coming back to the bifacial topic, this is a technology that will even allow us to get better solutions in the near future. If we look to the cell itself, not only the module, also the cell, it will increase the efficiency. And we can see it already with the new high efficiency cells that they can be either monofacial or bifacial. But when we speak about new technologies like heterojunction, like N-type TOPCon, these can also be used as bifacial for bifacial modules. The demand, I spoke about the demand, and in 2020, when I started working in LONGi, we had around 40% demand on the bifacial. Last year, we saw the switch, so it was not 40, it was around 60. And right now, year to date in 2022, I spoke with the sales directors of Europe, and they are telling me that we are almost in 80% of demand for bifacial. So this means that also with the decrease on the price difference between mono and bifacial, and with all the extra power, extra performance that we can bring from the bifacial, we are betting on bifacial. And this is a tendency worldwide. They are reliable modules, so we just hear also some notes about the behavior of the module. So we know from the monofacial, from the technology of the cells, like the P-type, the N-type, and so on and so on. But when we bring this to the bifacial, also these modules are very reliable. So if we look to the main parameters, like for example, the LID, the degradation that we have in the beginning of the production, or if we speak about phenomena like the PID, that on the module level is related to the type of materials and the quality of materials for our modules. Or if we compare degradations, the bifacial gives us a very good answer, better than the monofacial. So it means that besides we have extra production, we also are working with reliable modules. For example, this is a good case because this is real data. And if you see here in the first year degradation that the average of the warranty given by the manufacturers is around 2%, we are always below 1.5 or in some cases even below 1% degradation on the first year. And this is so true that we reflect it on the warranty. So the double glass solution, and we are speaking that in our case, we have the monofacial with a 3.2 millimeter glass plus back sheet. On a double glass, we have 2 millimeters glass, both sides. And yes, sometimes the people ask, do both glasses have AR coating or not? The front one, yes, is like the monofacial. The rear one, no, because we are treating a different type of light, and that's the reason. But in the end, the double glass solution protects more the active part. And this allows us to go down on the early degradation and increase in 5 years our performance warranty. This is also an important factor when we are financing projects, when we are doing our financing model. So the warranty here has also a role to play, and this helps also in our LCOE and so on. If we came from the modules and we look to the system, because one thing is to have a good module, a reliable module, a high efficiency module, but how shall I look to the system and get the best out of my bifacial installation? We heard already, and I think this is common knowledge, that there are different factors on the installation side that affect the module. In this drawing, for example, we see that we have different type of lights, that the lights are reflected, that we have scattered light, diffuse light, and so on. So what are the parameters that I should look to before I decide to go for bifacial? The famous albedo, so the reflection factor of the ground that allow us to get more or less light on the rear part of the module. The distance between the modules to the ground, because if we are too close to the ground, we will not have an harmonized and irradiance on the rear part, and probably parts of the rear part will not get as much light as others. So we advise minimum 1 meter distance to the soil. And if we go down of that 1 meter, we know that we are losing performance. Then the irradiance, and this is also regarding, for example, with the distance between rows, because if we cover the ground between rows in a way that the sun cannot be reflected, we will not get the same irradiance on the rear part of the other rows. The shading, we have to be concerned, and I know that during the trackers discussion and when we speak about trackers, this is also a topic that we mentioned, the cables, the tracking system, and so on. So we also need to be careful that the shadows on the rear part will also reduce the performance, and depending on the shadows can also bring other topics like hotspots and so on. And of course, the compatibility with the inverter. We don't have time to go on all the details about all of these parameters, but I will highlight and give you some numbers about how they impact really the installation. For example, the albedo, it's easy for us to understand that as higher is the albedo, better is the result we have. But for example, when we speak in albedos of 80, 90%, we are speaking 20, 25% more production. So these are percentages that are very interesting when we think about investment. And being a little bit more concrete, if we look, for example, to this table with real plants that we installed and that we studied, you can see that, for example, if you are around 80% of albedo, you can get generations around 25%. Okay, of course, that if we are with an albedo of 10%, we get a little bit less. What I see also is that, for example, in the distribution generation, thinking more on CNI, also we start to get some demands on bifacial. And on those kind of installations that they are smaller and they are more on buildings, many times the solution is to paint off-white and get a higher albedo because the investment to get this albedo is low. But I saw already some examples in a utility scale using white rocks or other solutions to increase the albedo, and the cost of this investment would allow to get 20-25% and compensate on the LCOE the cost of getting a higher albedo. If we look to the distance to the ground, what we see is that we advise 1 meter because below 1 meter we have losses, but if we go 1 meter or higher, we always get the same result. So what we advise is that if you simulate, if you calculate, and by any reason you cannot use the 1 meter, you should also consider that your result will not be the same. And maybe it justifies that you have 80 centimeters for the return that you have. But this has to be a balance, and you need also to look to this cost and to the result that you expect. More or less, we have the same topic with the balance on the distance, on the pitch, on the distance between rows. Why? Because we are speaking also of cost of the land. So if I'm saying that for bifacial, we need more space, probably we'll need more land. But this extra land also allows us to get more performance. So in the end, is a question of balance to get the distance we need so that we don't shadow the ground and be able to get the radiance with the extra production. The shadows, I already mentioned these, junction boxes, tracking systems, cables. So this is also has to be really well thought. And please keep in mind that if we are using bifacial, we need also to look to the right inverter. And this is a compatibility topic. And we need to consider that the inverter has to be adequate to the extra production that we and the extra current that we will generate. Okay? Going to more data, because I have 5 minutes to close the session. I also promised to bring some data. We saw already some, but for example, I think I passed one, yeah. For example, in this case, we are seeing that by using bifacial, comparing with monofacial, we got 23.7% more in Taizu in our test site. In this case, I think it's quite interesting because we are always simulating with tools, BDCs and others. And we always have the doubt if they are conservative, how much can I trust the results? And from our experience, all the results we got on site comparing with the simulations were higher. In this case, in Taizu also, when we simulated, we were 2.65% below the real results. So it means that probably when we simulate, we still have something additional. At least this is what our experience tells us. Okay. Another example, and maybe just to give you an idea, I gave you all these examples with tracker systems, because the topic here was the trackers. And from the 80% demand that we see in our modules for the bifacial technology right now, I would say that almost of them were with tracker systems. There are some exceptions, but I would call it exceptions. So I think that as a final idea regarding the trackers and these kind of solutions, the bifacial works good in fixed structures, but with bifacial, we also increase the production and the performance of our bifacial system. Okay. Another example, and with this, I finish my presentation just by leaving also this idea that the bifacial is here to stay. We are looking to new technologies of cells and modules, but the bifaciality and the bifacial solutions will remain. Thank you so much.
Vitor, wonderful. Thanks a lot for showing also how much bifacial alone already improves yield, and in combination with trackers even more. I think it's interesting that you also showed that that real data is better than PV-Sys. I had just one question. So from when is that? Because I heard recently that PV-Sys is getting better.
It is. It's true. The first versions, there were some issues. Also from the manufacturer side, we cooperated on this. For example, we have our own manuals how to simulate bifacial in PVCs and other softwares. And now the simulation softwares are getting more accurate.
Okay, cool. Thanks a lot. And there might be some in the chat. And yeah, once again, thanks.
Thank you.
Continue. So we